Understand definite limit notation? Definite integral notation?
I'm so sorry.
Be able to find the area under straight lines.
Because we don't do fundamental theory until.
Let's say under a function. Under a function.
But technically, you can't do that by the end of the chapter.
Yeah, you can.
You can take.
This is a function, right?
Some functions.
This is a function.
Yeah.
Yeah. I'm not saying all of them. You could say under some functions, under some linear functions. You could say that if you wanted to. All right, how does one determine the area under a curve without using Riemann sums? They can be found using integrals, ones that are constrained to find only a specific area. Definite integrals.
Kind of weird.
Yeah, it's a little awkward. I'll let you change that. Definite integrals are integrals that occur over 2 points and represent the area between those 2 points. Not really. They represent the area under the curve between those 2 points. The integral between these points can be denoted as that. Where is this image from?
I'm pretty sure it's from College Board.
If you don't know where it's from, then we can't use it. So, either figure out where it's from, make sure it's public domain, or you can make your own, take a picture of it, which is fine. Yeah, that's always easy to do.
If you have a Mac computer, they have one of those grapher things in it.
Well, I don't know, because you probably want to hand draw something if it's kind of just a weird nonsense function. You're just saying from A to B.
When it says you'll have to add them together, what does that mean?
The positive area, you combine the positive and the negative areas.
Cool. So go ahead and actually say that.
All right.
This is just slightly confusing. I know what you mean, but somebody who hasn't learned it yet probably won't know what you mean. In the situation depicted to the left, there's no situation over here.
I took it out. And I forgot to take out the paragraph.
The area is the total, so change that. The area is the total blue area minus the total yellow area. So either change this or remove it. There will be easy ways to calculate this. Later, rules of definite integrals. If this is a section title, I would put it in bold. Taking the integral, is this from College Board too?
Okay, I actually don't know what that
Same thing. If you don't know where it's from
I'll make it.
and you can't verify it's public domain, make your own. Taking the integral from right to left from B to A gives a result negative to the... This is worded a little awkwardly.
I'm not sure how to word it, actually, honestly.
So what if you said, if you take the integral from B to A, it will change the sign of the
That's also kind of weird.
area from the integral from A to B. You could also just have this. And actually, I would phrase this the other way. I would say that the integral from B to A is the negative integral from A to B of f of x dx. This is not wrong. It's just not how I would phrase it.
You're not wrong.
This is good right here. This line right here. An integral with no length. Integrals don't really have length. Let's say an integral from a point A to a point A.
Well, that's what it says there.
This says no length. Integrals don't have length.
Yeah.
You can't say length.
I guess.
It's a mathematics thing. It's a conventions thing. Alright, it can be useful to separate two functions within an integral. And let's say and add them separately. Okay? I know what you mean, but I just want to make sure it's crystal clear for people. Cool. You should see how you're doing commentary for everything. You did a commentary for this guy, you did a commentary for this guy, you did a commentary for this guy. There's no commentary for this guy. So just add some commentary for him. Maybe something to the effect of, if you have a constant inside of an integral, you can pull the constant out. It also might not be a bad idea to show like just do like 4 f of x or 5 f of x or something like that, and then just pull the 5 out in the front. That's always helpful for people to see examples. The area of a section A to B. Let's say the area under the curve from A to B. In the top figure, what's the top figure?
The top figure's the one to the left, but
okay, so
before Georgia 20.
Right. So rearrange that. So that makes sense.
You know,
Is the same as area of A to C. Instead of saying plus, let's say added to the area from. So instead of that, say added to the area from. All right. This idea can be applied to finding the area of a line. The area of a line. Lines don't have area.
linear function.
How about finding the area under a linear function? Using triangles. The integral of the line 3x plus 1 can be represented as such. You didn't actually write it. So if you're going to show the picture, then what you'd want to do is drop the picture down there. Maybe make it a little bigger. Or refer to the picture below and consider, and then what I would do is actually show integral from -2 to 4 of 3x plus 1 dx. And say, hey, that is depicted in the picture below, where blue is positive, red is negative. The area values in this situation can actually be found using geometric triangle formulas. Good. There will be different theorems in later chapters, but they aren't necessary. The definite integrals of straight line equations.
Linear functions.
Linear functions, good. I like that. Start by finding the height of the positive area. So maybe put something in, like depicted in blue. People should know which one the positive one is, but people don't. 3 times 4 plus 1 equals 13. What is 3 plus 4 times? 3 times 4 plus 1.
That's the function result. Like at the end of the function. Oh shit! I forgot to write the constraints. Yeah, I probably have to write down the integral as well.
I would say not the length here. I would say the width. So sideways width. This value stops when the y value equals 0. It would be helpful to have a picture here. I would actually do this with a video, personally, if it was me. I would show it, writing it out on the paper with a video.
I'm really bad at videos.
Well, okay. But this is just going to be really confusing for people as they read it with words. It's much, much easier to understand with a video.
Yeah.
Find the value of the positive area. Do the same thing for the negative area. Again, yeah, I would say video would help. Homework. Homework looks good. So yeah, overall, not bad. Make sure these guys are public domain. These rules, I'm glad you included these. Overall, like, looks pretty good. You'll just have a lot of little things to change. So, all right.